Lecture 12. Today we are going to be talking about persistence. That is how to make things stay on your device even when your app gets killed or quits or your device restarts or whatever. And also, eventually, we're going to talk about persistence on the internet as well, where you want data to live out on the network. So if you're lost your phone or something, you would find it. So today is really just part one of that. We're going to talk about local persistence, persistence on your device. And even that, we're not going to talk about all the ways to do persistence because, for example, our little object-oriented database that we'll talk about later is a really powerful way to do persistence that we're not going to talk about. And then we're going to go into emoji art and see this in action. We're going to make our emoji art document persist, because as you all know, working on your assignments, you move a little emoji around and then you run again and it's gone. You have to start it again. So we're going to make that persist. And we're also going to make our palettes persist, right? We have those palettes and we can create a new palette. We can delete a palette, but it forgets every time we rerun. We're going to fix that. And then after that demo, I'm going to go back to the slides and we're going to talk about property wrappers. That's all those things to start with @ sign state, @ sign published, @ sign observed object, all those things. We're going to talk about what are those things really and what's going on there, help you understand that. So let's talk about persistence, or at least part one of persistence here. And there's a lot of different ways to persist things in iOS. In the file system, of course, it's got a Unix file system. We can put things in there. SQL database or some other kind of network database, you can store things in there. And there's an incredibly powerful object-oriented way to do that called core data, layered on top of SQL. The cloud, right? iCloud, and store a lot of things there. And these things I mentioned, core data and the file system, they actually interoperate with iCloud. You can kind of make it so that the data you store there automatically gets put on the cloud. And there's this whole framework called CloudKit, which lets you create records and store them in iCloud and all that. So there's a lot of that to do persistence. There's a lot of third-party options as well, especially for storing things on the network. And last and definitely least, there's user defaults, which is this really like a persistent dictionary that you can put stuff in, but it's only for lightweight stuff, user preferences. So today I'm going to talk about the first thing there and the last thing. I'm not going to talk about any things in the middle, and we will talk about that later in the quarter. Let's talk about the first one there, which is storing things in the Unix file system. I don't think everyone knows this, but iOS underneath is essentially a Unix operating system, and it has a Unix file system. And there's file protections, of course, in that Unix file system, so you can't see everything in there. You can't see the system files and all that. And in fact, it's a little more formal than that. You can really only see the files in there that are in what's called your sandbox. So why do we have this concept of a sandbox? Well, obvious reasons, as you might imagine. For security, you don't want any other app to be able to reach in and damage your app by deleting a file or something like that. Also privacy, your app is collecting user data. You don't want other apps to be able to look at what that is. Some other lesser known but important ones, clean up. When you delete an app from your device, you want it to delete everything that came with that. All the data the user created, everything gone. And since when you delete your app, the entire sandbox is deleted, everything gets gone. So there's not going to be cruft left over on your device after you delete an app. And also backup, right? When you back up your device to iCloud or even to a computer, you want your entire sandbox to get backed up. Well, actually, not really. You want most of your sandbox to get backed up, but not everything. Like your application itself is in the sandbox. You don't need to back that up because you can just download it again from the App Store or whatever. But all the user's documents they've created, you definitely want that backed up. And so that part of the sandbox is backed up. So the sandbox is smart about what gets backed up, what doesn't, etc. So what's in the sandbox? What are some of the directories, these Unix directories in the sandbox? There's the application directory, that's your executable, and also any images or other things that you bring along with your app that you're going to present. That part of your sandbox is read-only, so you can't go and edit your executable on the fly. We don't allow that. And then there's also other places that are editable, though, like your documents directory and your application support directory. These are two very important places in your sandbox. The difference between the two really is just whether the user perceives the data that they've created as a document. Like an emoji art, it would definitely be a document, right? If you created that, so that would be in the documents directory. If it was just other information, like for example, in what you're going to be doing for assignment 6, where you're going to have your memorize, you're going to have themes. Maybe the themes aren't really documents; they're user data. You'd store them maybe in application support. All right. I think in your assignment, you're probably going to store it in user defaults because it's really easy. But if you're going to store it in the file system, that's the kind of place it would go. And then there's other ones like the caches directory. The caches directory, you can put anything you want in there, but it doesn't get backed up. So anything you put in there wants to be something you can recreate. Right? So if you're a Safari app, then it'd be like pages that you cache from the internet. You can always go back and get them again, but you like to have them local to make things fast. That's what the caches directory. And there's other ones. If you go look at the documentation for URL, you will see what those things are, as I'll show you here. Now, when we want to access our sandbox, we obviously have to start in one of those special directories. Those are the only places we know how to find out where they are in our sandbox. And once we find it, then we're going to add paths to it to build directory structure and create our files, etc. And you get the URL to these things via these statics in the URL struct. So you just go look at URL and you'll see them, url.documents directory, your documents directory, etc. Now, I've been mentioning URL here. Maybe not everyone's aware. Everyone knows what a URL is. I'm sure people know that http//something, that's a URL to something on the network. Well, there's also URLs for things in your file system. They look like file:/ some Unix path, right? So when I talk about URL, I'm talking about the path to a file. Essentially, URL is the struct we use to have paths to the files, And you create those paths by taking one of those sandbox directories and appending path components to it. So these URL functions, append path component and appending path extension, append these things to you and give you a new URL. So if I wanted to create a document called filename.doc in my documents directory, I would just say url.documents directory, appending path component, and I would get a URL to that thing. That's how I'm going to build files and do everything. Is by building these URLs. Now, URL has other stuff in there that I'm not really going to talk about, like you can ask, is this URL a file URL or is it an HTTP type thing? You can find that out. And it also has all kinds of resource values you can get about the file, like the creation date, whether it's a directory, how big it is on disk, those kind of things. You can get all that with functions on URL. So URL is a really powerful way to access your Unix file system. A lot of convenience mechanisms there. But it's not the only way. For example, how do I store stuff in the Unix file system? Right, I've got a URL, and now I want to put data in there. Or I've got a URL that I put data in the past, now I want to get it back. Well, one of the primary ways we do that is actually with the data struct. And we've mentioned data briefly. Data is just a struct, which is bag of bits. It's one of the fundamental types, kind of like int and float. There's data, right? It represents just a bunch of bytes. And when we're reading and writing to files, a lot of times we're just grabbing all the bytes out of them or putting bytes into the file. So data is one of the primary ways that we will access it. And so how do we read and write data with the data? Well, there's a initializer called contents of URL. You can create a data by looking at the contents of a URL. And yes, that does work with HTTP URLs as well, although we almost never use this because it blocks. You can imagine when you say, give me the contents of URL, it could take 5 or 10 seconds because the network's really slow, or it might take a long time because the network's down or something. So we don't usually use it for that, but it's great for file access because of SSD or whatever inside of your phone, you can get it real quick right away. One thing about creating a data with the contents of URL like this, you'll notice that you have to put the word try in front of it. See that? You can't just say let data equal data contents of URL. You have to say try data contents of URL. And that's because it can throw an error. And we haven't talked about error handling. We're going to talk about it in part 1 of that today. But all of these I/O things tend to throw errors when there are problems, like your disk is full. It'll throw an error at you, whatever. So you'll see this red try and throws on a lot of these slides. Don't worry about it. I'm going to talk about it in a few minutes, what that is and how we deal with functions that can throw, like this initializer for data. So how do I write the data to the file? That's, I can create a data with the contents of URL. How do I write it out? Well, data has a function called write to URL, and you just write this data, all the entire data, out to the URL, and it has some options for writing there, which you can look at in the documentation. And this one also throws. This one, you can obviously imagine why this one would throw, because the disk could be full. It's like, disk full, throw an error. But even the one on top, contents of, if it was an HTTP one, it could throw an error, network inaccessible. Can't get to that. Right? So that's data. So we have URL and data, and there's one other struct called file manager. And file manager is used to manage the file system itself, copy files around, create directories, list directories, see what's in there. That's all file manager. And we're usually going to get the default file manager, which is filemanager.default, is a static. And we're going to do all these operations on there, like copy and move and file exists and all these things. So you can go look at file manager. It's surprising we don't do this that much. I mean, usually we're just getting URLs and then reading or writing to them, but occasionally you'll want to be able to list the files that are in a directory or whatever, and that's what file manager is for. Using URL and data in file manager, that's how we access the Unix file system. But how do we kind of create the data that we want to put in the file system? So we're reading and writing data, but the data in our app is not usually a bag of bits. It's a struct, which has a whole bunch of stuff. Like imagine our emoji art. Our emoji art has all those emojis and the background URL and all in there. That's the thing we want to put in a file if we're going to save our file to disk. So how do we turn a struct, a random arbitrary struct, into a data so that we can write it with that data write to URL thing? We do this with the codable mechanism here. And it's essentially a way to gather up all the vars of a struct and smash it into a data. Specifically, the format of that is going to be JSON data. How many people here have heard of JSON? Know what that is? Everybody, no, almost everybody. So JSON is just a file format. It's actually a text format. It's used a lot in the internet to communicate information around. It kind of has arrays and dictionaries of things in there. I'll show you what a JSON looks like in a few slides here. But what this codable mechanism does is it takes your struct and it turns it into a JSON, all right, which is a big string. And then that string gets encoded into a bag of bytes, the data, and then you write it to a file, and then vice versa when you're coming back out. So how does codable work? How do you make something codable? How do you take your struct and make it codable? Well, it just has to implement the codable protocol, as you probably imagined. Now, codable is so important that Swift will really help you here. So if you have a struct and all the variables of that struct are codable, then all you need to do to make your struct codable is say :codable, right? You just say you implement codable, it will do it automatically, as long as all your vars are also codable. Same thing for an enum, as long as your associated data is codable, then it can code that. But if you have vars that aren't themselves codable, or let's say you're a class, right, instead of a struct, then there's a whole API for how to implement some methods to make yourself codable. And I'm not going to talk about any of that in this quarter, but you can go take a look at the codable documentation and look through all how to do it. You won't have to do it. We're always going to try and design our structs to always use codable properties. That makes it easy on us. Now, the way that that's even easier is all these types are all codable, right? Not just strings and bools and stuff like that. Optional is codable. Also, array and dictionary and set and data itself is codable. So you can see all these things are commonly used. You can build a lot of powerful structs out of these primitives, and they're all codable. So you're good to go. Now, once your struct is codable, how do I turn it into JSON blob? How do I get a data with JSON in it from it? So easy. There's a thing called a JSON encoder. You see it there, and it has a function on it called encode, and you just pass your object to it, and it will pass you back a JSON blob of data, exactly what you want. You just say JSON data equals JSON encoder, encode that object. Of course, the object has to implement codable for this to work. And notice this one throws. This one throws, and you have to try it because maybe it can't encode that object for some reason. It tries to and it fails. So you have to try and throw this one as well. But it couldn't be easier to get a data from a struct that's codable. Now this JSON, it's not a binary format, it's actually a text format. So if you want to turn that data blob into a string that you can look at it, right? Look at the JSON string. String has a nice initializer, which takes the data and the encoding. JSON happens to always be encoded with UTF-8, which is a Unicode 8-bit bytes format. And if you do that, you'll get back the string and it'll look like JSON that you're used to. Now, you can also take that data blob, of course, and write to URL because it's a data. So you can do write to URL. Of course, that throws, as we know, so you have to try it. But what about going the other way? What if I opened up my file and got the data out, and now I want to turn it back into my struct? We can do that with a JSON decoder. So the JSON decoder, it has a function decode, and you tell it what type you want it to decode. Remember, if you want to specify the type of something, you say the name of the type, .self, that means the type itself. We saw that when we did the drop destination. Remember, we were like, what kind of type you want to drop? And we did strl data.self. Here we're doing my type.self, and then from the data blob, the JSON blob that you want, and it will return to you an object of your type. So if this was an emoji art, I would say JSON decoder, decode emoji art.self from the JSON data, and I would get back an emoji art. And again, this can throw, because this JSON you give it could be just a mess, it could be nothing. So clearly this has to throw to say, I couldn't find an emoji art in there. And here, notice that I'm trying it with a question mark. And this kind of trying, I'm going to talk about it in a second. This means try this, and if it fails, just return nil. I'm not going to look at the error, but just return nil. So that's what that try question mark means. So this is how you would decode something that you found in a JSON data object. So what does it look like to make something codable? Well, you just put :codable on the end of it there. You can see these bars are all codable because I'm saying that some other type is also codable. And the JSON probably looks something like this. This is what JSON looks like. It's got a lot of curly braces and colons and commas and all that stuff. But that would be the JSON for that thing. Okay, the last thing I'll talk about briefly here is user defaults. User defaults, really not that important of a persistence mechanism. It's really for things like settings. If you have settings in your app that you want to remember, we're going to put our emoji art palettes in there. That's right on the border of whether that's too important of a thing to put in user defaults, but we don't actually manipulate our palettes that much. So it's probably fine. It's not that much data. But user defaults is essentially just a persistent dictionary. It looks like a persistent dictionary. Now, it's not the dictionary, but it's like a dictionary in that it's got keys and values, and those keys and values persist. To use it, you need an instance of it, obviously, so you are almost always going to use user defaults.standard. That is the big shared dictionary, persistent dictionary you'll use throughout most of your app. Okay? And that has a ramification that you're going to use this one throughout your whole app, which we'll see in a minute. So how do you store something into this persistent dictionary? Use this one function called setObject4key. Just send this to the user defaults.standard there. And the interesting thing about this is the object that you're going to set for that key in this little persistent dictionary-like thing has to be what's called a property list. Now this is an ancient API, this user default. It's 20 years old or something. So that property list thing is not a protocol or some kind of concrete type. It's just an idea, all right? So the property list means strings, ints, doubles, arrays of those things, dictionaries whose keys are strings and whose value is one of those things, and also data is a property list. So all property list means it's one of those things. That's what property list means. And that's the object there has to be that. And you'll see in the demo, I'm going to try and pass some other kind of object there, and it's going to complain. You'll see the complaint that it makes there. But since data is a property list, well, that means any codable thing can be put in to user defaults because you can just turn it into a JSON first and then throw it in there. So it's pretty flexible, actually. So that's how you put stuff in, just with this one function right here. Remember I said that this user's defaults.standard is the one that we're going to use pretty much throughout our whole app. You want to be careful about these keys that you use. You don't want them to be really generic because you might have some other class or function, struct, whatever, that's trying to put something in there with the same name. So you wouldn't want key names here like in our emoji art, we called our palettes main, the main palette. Main is too generic of a word to be a top level key in user defaults. You'd want to namespace it a little bit. So be careful about that. You want these keys, you got to remember these keys are going to apply to your whole app. So that's how you put data in. How about getting data out? Well, there's a whole bunch of convenience functions in user defaults to get the data out in the type you want, like integer for key or data for key or URL for key. They are going to return something that you set for key in the previous slide as that type. Now, of course, maybe you set it as one thing and you tried to get it as something else, and this is going to fail. That's why all of these, you see, they return optionals. Because either you never set something there or you set something of a different type, and when you try to get it, yeah, can't do it, so it returns nil. And there's a nice one here to know, which is string array, because putting an array of strings in user defaults is a common thing to want to do, so there's a way to get array of strings back out. Getting a dictionary or an array out of there that's not an array of strings is tricky, and I recommend against it. I actually recommend just use Codable and create your own struct and put it into a data, make it JSON. That's because if you call the function array for key in user defaults, it's going to give you an array of any. And we have not seen this type any. It's kind of this type for mostly backwards compatibility with the old world of UIKit. It means an array of something that you don't know its type, and you have to then use this operator as in Swift to try and turn it into the type you want. Oh my gosh, just forget about all that. Don't use array for key or dictionary for key in user defaults. Just make your own struct, put it in, make it into a JSON and put that in there. All right, let's talk about that error handling, the trying and the throwing that you saw with some of these things. And why do we have this throwing of errors? Well, the alternative, if we didn't have throwing of errors, would be that functions would have to return an error code. And this really gets messy if you have a function and it returns something else normally, but then if it has an error, it has to return an error code. So now what are you going to return? Either an enum with success and failure, which people did for a long time, or like a tuple where there's the right answer and then an error answer. It gets messy. Whereas if you throw your errors like this, then you can make it so that your API looks normal as if there are no errors, and then you have to catch the errors that get thrown. The other thing about throwing errors is you're going to see in the demo, sometimes the code that tries something, it doesn't want to handle the errors, but it wants somebody else to. So the good thing about try is you can rethrow them up the stack frame until somebody handles them. Right? It's also easy to ignore errors. You get an error thrown, you're like, I don't care, I give up or whatever. You can decide what you want to do. And so that's very easy to do as well, as you're going to see here. So we're going to talk a lot more about handling errors when we talk about asynchronous programming, multi-threading next week, because they really work together beautifully, having thrown errors and things happening asynchronously. This is the part one of throwing. So let's talk about the basics here. When a function can throw an error, it is always marked throws. At the end of its declaration in the documentation or whatever, it's always going to say throws. That means this can throw an error. If you want to call a function that throws, you have to try it. So you always must use the keyword try when you call a function that is marked throws. There's no exceptions to this. You always have to do this. Now, let's talk about 4 ways to deal with trying a function that might throw. 3 of them are to basically ignore the error, and 1 of them is to handle the error. Let's talk about the 3 ways to basically not handle the error. An error happened and you're not going to do anything about it. The first one we already saw, try question mark. That means try this, completely ignore any error, just do nothing. And if I'm calling a function that returns a value, have that thing return nil instead. So it turns the return value would normally be, it turns it into an optional, because now it can be nil if that thing fails. When you do try question mark, it makes it so that like data contents of, which normally returns a data, now it returns an optional data because it might fail. So let's try question mark. Kind of complete, that's the ignore case, just ignore the failure. Then there's try exclamation point. That means crash my program if this thing throws an error. So this is one that you put in there a lot in development when you're calling something that should never throw an error, and it does, and you want it to crash, so you have a nice back trace and you can go debug and see what it is. You don't use it as much in production code, although you might, because there might be times where you're just certain that thing's never going to throw an error, so you're going to do try exclamation point. And then the last way to kind of ignore it is to rethrow it. Here's a function foo. It's trying something that can throw, and it doesn't want to deal with this. If this thing throws an error, it's like, I don't know what to do, so I'm going to throw. So if you mark a function itself as throws, then inside it can call things that throw. And if those things throw, it'll just throw it up to the person who called foo. And that means whoever calls foo has to say try foo, because foo is now marked as throws. You see? So I'm just throwing it up the chain, right? I'm punting unless something else deals with it. So these are the three ways if you don't want to deal with an error yourself. Now, what if you do want to deal with the error? You want to see what the error was and do something about it. Clean up or do some alternative thing. To do that, you wrap your call and try with a do catch. So you just say do, open curly brace, any amount of code you want that can try as many things as it wants. And if any of the things inside there throw an error, then you can catch that error. Now this catch let error right here is the catch-all catch. It catches any error thrown and assigns it to a var called error. And you could say catch let foo, that would be fine, and then it would catch it and throw it in a var called foo. Inside this curly brace area here, you would then handle the error inside there. You can look at the error, see what it is. Error, by the way, will always be something that implements the error protocol. Now, it could be a struct, an enum, anything that implements error. The error protocol only has one thing in it, localized description, which is a string that describes the error that nominally might be something you could throw in front of a user even. But mostly here, when you're catching errors, you're looking, if you want to catch specific errors, you're going to look at the actual type of the error. What is the enum that got thrown? What is the struct? We're not going to look at any of that today, but I will be looking at that next week when we do asynchronous programming, because we will be throwing errors and wanting to look at which error happened. All right, so let's go into the demo and see all this in action, all the things I just talked about there. We're going to access the file system. We're going to be trying things to throw. We're even going to use user defaults. Before we start, I'm actually going to do something real quick, which is a couple of you on the forums were saying, oh, I dragged an image into my emoji art and it just did nothing. It didn't work. And we don't really report any errors in our code here when we drag a bad image into our emoji art, right? We just ignore it. It's just like it didn't even happen. So I'm going to put a little code in here that lets you see when that happens, see an error when that happens. And that's because async image does have some mechanism for handling this. Now, when we do our asynchronous demo next week, we're going to do async image ourselves, and our error handling is going to be really good, okay, because we're going to be learning about error handling. Async images error handling, it's minimal, but it goes like this. You can put a little closure after here, and it'll pass you this thing called the phase, which is the phase of the image loading that's going on. And then you can look at the phase. And for example, if the phase has an image, then you can just use the image. This is essentially a view builder in here. So I'm going to return which view to show. So here I'll say if I can let image equal the phase's image, then I'll use that image. Otherwise, if I'm fetching, so I'm going to say if I can let URL equal our document's background, so it has our background has been set to some URL, then if the phase has an error of some sort, then I'm going to just put the URL of the background on the screen so you can take a look at it. Otherwise, I'm going to do a kind of a cool thing here, which is I'm going to use a progress view. So remember, this is a view builder. My async image here is asking me to return, put an if in here, return the view to use to show this async image. And I'm either returning the image itself, if I've been able to get one, or I'm returning a text that shows me the URL that was bad, or I'm going to show a progress view. Progress view is the little spinning dial. You know, you've seen the little spinning dial, like, wait, I'm doing something. So let's try this and see what it looks like here. Go get here. Here's the background. This one, successfully the spinning thing. Spin, spin, spin. It's loading it. This was obviously a very big file. And I think this one right here has got a problem with it. It won't work. So I'm dragging it in. It says it's working. And I hit, oh, error. And it's showing me the URL that failed. Why did this URL fail? It's HTTP, not HTTPS. It's an unsecure HTTP. Now, there is a way, I'm not going to show you, to make it so that your app can accept unsecure HTTP images, but that's why this one failed. Now, over back in our code, we didn't look at this error, this phase.error, but it's actually an error protocol error. It was thrown, and it's being passed on to us, so we could look at it, look at its localized description, maybe even put that up. You can do that if you want. I just wanted to show you basically how you do this. And I'm not spending any more time on this because, like I say, we're going to write our own async image equivalent that's way better anyway. Okay, now to persistence. And what we want to do for persistence is auto-save our document. We're eventually going to have multiple documents, so we can open multiple emoji arts, but right now we only have this one, and every time we run, it's reset to a blank document, and we want it to save. So we're going to add auto-saving to our emoji art document, and all of our saving and all that is going to be in our view model, because our view, its job is to present this thing. Our model, its job is to be this thing. So who owns saving it on disk? Well, that job falls to the view model, our emoji art document right here. And it's really easy to make this auto save. You see, here's our emoji art model. It's going to say, whenever it changes, please auto save it. And what is this auto save function? It's a little private func auto save. And what do I need to do inside autosave? I'm just going to save it to some autosave URL of some sort. Let's go ahead and make that a little private let autosave URL. And this autosave URL is going to be obviously something in our sandbox. What in our sandbox? Well, it's going to save to our documents directory because emoji art is a document, so that's where it belongs. So I'm going to say url.documents directory. Now I have to give it a name, so I'll append the path component. I'm going to call this autosaved.emojiart. I haven't really invented a type for emoji art. That's what this conforming to wants. It wants to know what is the type of document. We're eventually going to invent an actual type.emoji art, but for now we're not doing that, so we won't specify this conforming to. And there we go. We got our autosave URL in our sandbox, and that's the file we're going to save things to. Now, when we save it, let's go ahead and put a print out so that we can see this is happening. I'll just say print, I auto-saved to that autosave URL, and then it'll also give us a chance to see what this autosave URL into our sandbox looks like on our simulator anyway, which is kind of fun. So what about save to? We need to do that. All right, private func save to a URL. And how do we save to a URL? Well, we're going to have to write it to that file. So we're going to have to create some sort of data and write it to the URL. And what kind of data we're going to do? Well, of course, we're going to let our data equal our emoji art as a JSON. I'm going to do exactly what I said in the slide. I'm going to convert my emoji art into a JSON data, and then I'm going to write that data out to that URL in my sandbox. To make this all work, we of course have to implement this JSON function, and we know how we're going to do it, right? We're going to use that JSON encoder and all that stuff. So let's go over to our emoji art right here, and we'll have a func, public func called JSON, which returns a data. And how do we do this? One-liner, JSON encoder, encode myself. That's it. That's all that's required to do it. And we got an error here. What does this error say? Instance method encode requires that emoji art conform to encodable. Now, I told you it was called codable, not encodable, remember? Well, codable, that protocol is really just two protocols, encodable and decodable combined together. So I'm going to make emoji art conform to both encodable and decodable. This is exactly the same as saying codable. That's just the combination of those two. It only makes sense to kind of do both of them. Why would you encode one? You can't decode it. And when I say that up there, it says emoji art does not conform to the protocol decodable. Why is that? Well, that must be because not all of its vars are codable. So let's look at all of emoji art's vars and find out. Background is a URL. Is that codable? Yes, definitely is. Emojis is an array. Is array encodable? Yes. Of emoji, oh, is emoji codable? Oh, let's look. Here's emoji right here. Doesn't look codable to me, but how about if I say, now it's codable? Woohoo! When we do this, we get another error. It says emoji mark.emoji does not conform to convert. Oh no, let's see. String, yeah. Int, yeah. Oh, position. This guy. Okay. Codable. And we're winning. Now everything is codable. So this is just to emphasize that when you have substructs, you need to go mark them codable as well, because everything needs to be codable all the way down. And sure enough, no error up here anymore about that. But we do have an error left. Call can throw, but it's not marked with try. And that's, we know that JSON encoder can throw errors. So if we want to call this, we have to say try. Now we're going to get another error here. So what is this error? Errors thrown from here are not handled. So I say I'm going to try that thing, but I don't say what I'm going to do about it. So what am I going to do about it there? I might be tempted here to use try exclamation points because I know I can be encoded. Oh, look, I only have ints and strings, although I do have that URL up there. I might be a little worried that encoding that URL, maybe that could throw an error. I don't think so, but nah, I'm not going to use try exclamation point. It's just too dangerous. But what am I going to do here? Well, I could do try question mark and return nil. That would be one option. But just to show you how it's done, I'm going to actually have this thing rethrow the error. So I'm marking this JSON function as throws. And look, no more error. Because if that try throws an error, it's just going to throw right up to whoever called me. Now, another thing I'm going to do while we're in here, let's go ahead and print this out so that every time somebody asks my emoji art for its JSON representation, we see it on the console, just so we can see what the stuff looks like. So I'm going to say let encoded version of this equal this. And I'm going to do that thing from the slides, which is I'm going to print this out. I'm going to say emoji art equals backslash parentheses string, give the data to it, which is this encoded data, and the encoding of it is UTF-8. And that might fail because maybe there's not UTF-8 in there, I guess. And so if that fails, we'll just say nil. Emoji art equals nil on the console. And then let's return this encoded data. So encoded is a data struct that has JSON in it. And we're going to use that string initializer to just grab the string out of there, the JSON string encoded as UTF-8. So now we absolutely know how to turn our emoji art into a JSON. We can go back to our view model and use that here. See what it says. Ooh, call can throw, but it is not marked with try. And sure enough, we know that JSON can throw, right? Right here it says JSON throws. So I'm going to have to say try to do that. And what about this one too? Call can throw, but it's not marked down here. Well, of course, data write. It can throw as well. Disk might be full. Got to throw that error. Now, how are we going to deal with this thing right here? Well, we could throw again and then make the person who called save deal with it, but it's time to actually handle the error. So let's handle these errors. I'm going to go just put a do catch around this thing. Catch, let error. And then inside here, error is the error thrown. I can go look at that error, see what type of thing it was. Was it a network error, some kind of encoding error with the JSON, whatever. Now, I'm not going to do any of that here because we'll talk about that next week. So instead, what I'm going to do if I get an error is just print that localized description out on the console. So we can see what it is. So I'll say here, print emoji art document, error while saving, and we'll just put the error.localized description in there. Not really handling the error that much, but at least I'm doing something here. Yeah. Yeah, so the question is here, what happens if this has an error and this throws an error? As soon as this first one throws an error, you're down here. So it'll never even get to the right. That's another good thing about throwing, is once it throws an error, it stops executing the rest of the lines there, because if you threw an error, you probably can't continue. And that's certainly true here. If we throw an error in doing the JSON, we certainly can't write it out. So we don't want to even try that. I actually think this is all we need to make things work. Let's see if it's working. I'll run over here. Here we have our document. Let's go and give it a background. We already have a couple of emojis there. Well, let's put another thing in here though. How about airplane? It's always a good one. Put in the sky up here. Now hopefully this has been auto-saving. Every time we changed our document, it's supposed to auto-save. So I can look at our console. Oh, look, there it is. It's auto-saved it quite a few times. The last time it saved it right here, this is what JSON looks like, right? Emoji art equals. Here it's saying I auto-saved to this file. So this long thing, users, blah, 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 all the way, this monkey number, data, containers, all the way past, all the way to here, that's the directory of our sandbox on the simulator. If you were running on a device, that would look quite different. You wouldn't have all as much junk there. But if you ever want to go look in your sandbox on the simulator, you can just print out the URL to it and go look there. It's, it's in your Finder, you can go look for it. And then you can see it's in the documents directory, which happens to be called documents, and there's our auto-saved. And then here is the JSON that was produced. And here's our emojis array, this open square bracket thing. And look at these. See, there's the bike. Here's the flame. There's the airplane, size and position, also their ID, their unique identifier. And then here's our background, which is this HTTPS thing. We have not done anything to look in the file system and pull the stuff out of there. We're only saving, we're not auto-loading. We're gonna do that in our init. Instead of having the bike and the flame, those are finally gone, we're going to load this thing up. So what do we need to do here to load this thing up? Really, we need some more help from our emoji art. Just like our emoji art can generate itself as JSON, it really needs a way to init itself as JSON. So you're going to give it some JSON data, and it's going to initialize itself, create itself. And that's really easy. It's going to set itself to be JSON decoder dot decode emoji art dot self, please, from the JSON data that was handed to it. And that's all it needs to do. Notice I'm in an init and I'm saying self equals, totally allowed, because I'm a value type. Value types can replace their entire selves with self equals, and that's all that's happening in that init. Call can throw, but is not marked with try. Of course, decoding can throw. What if that JSON is like just a curly brace blank mess, or who knows what's in there? So it could throw. So we have to try this. And we're going to go ahead and throw this on up too, so that anyone who is trying to create an emoji art from the JSON data and it fails, they can go look and see, well, why did that fail? I thought it passed it some good JSON, and it can look and figure out what's going on. Let's go back to our emoji art document. We're going to see a little error up here that we didn't really expect. Missing argument for parameter JSON in call. This is where I'm initializing my emoji art to a blank emoji art document, right? When I first have my var being initialized there, my publish var. How come this is now expecting JSON? Well, why did it work before? It worked before because it was using the free init that structs get. And since if you look in our emoji art, background is URL, it's kind of free equals nil, right? Because it's an optional. There was nothing to initialize, so init with no arguments worked. But now I've added an init JSON. Now I don't get the free one. When you add an init to a struct, you lose the free one. So if we want that init with no arguments, we have to put it here. Luckily, it's easy to implement because we don't do anything, but we have to explicitly put it back. So now if I go back here, you'll see this error will go away. All right, now that we know how to create an emoji document from the JSON, we can go back to our init here and say, let's set data equal data contents of URL, being our auto-save URL. So now I've got the data back out of the file system, and now I can say, let my auto-saved emoji art equal an emoji art from that JSON data I just got. And then I could say, set my emoji art equal to the auto-saved emoji art. Now this is all great, except call can throw. These things are all throwable, right? We know that data contents of is throwable. We know that we made it so that our emoji art init can throw if it can't figure out that. I'm going to use try question mark here, which basically means if I can't get this to work, then I'm just going to use a blank emoji art. The blank emoji art that I created up there, I'll just stick with that. I won't reset it. So I'm going to use try there, and I'm going to use try question mark here also. And I'm going to if let these things to see if all these things are true. So I'm going to if let that one, and if let this other one. And if all those things are true, then I will do this. Let's go back here and create a new document. Go here, this guy. Got our background. Let's go put a helicopter. You can see here it's reloading the document. It comes back, picking the URL. We got our helicopter up there. We put another thing, rocket ship, up here as well. Go back, rerun our app from scratch. Yep, there's the rocket ship. It's reloading the URL. All right, let's do our palettes. You see the palettes right here? If I go into my palettes and say new, and it adds this math palette, well, if I go back here and rerun, when I come back, oh, math is gone. It didn't remember that I had added the math palette. Or if I delete something, like let's get rid of sports. We don't like sports. Go back here and rerun our app. Oh, sports is back. Oh no, sports is back. So we want to make it so that whatever we're doing here with new and delete to our palettes gets remembered. And we're going to remember it in user defaults, mostly because I already showed you how to do it in the file system. And user defaults, I want to show you how to do that. But it's probably not inappropriate, as we were talking about before, to do it in user defaults. It's a pretty small amount of data. How are we going to do this thing? I'm going to do this in a really kind of a cool way here, which is, you see, here's my palettes, my published palettes that are in my palette store. I'm going to get rid of this and turn this entire palettes thing into a computed property. And I'm going to get the value of my property from user defaults. So I'm going to go out to user defaults and say, give me the palettes for a key, the name of my store. And when I set this thing, I'm going to set it in user defaults. Set my palettes. This is the new value for key name. And this, if it worked as is, would just work. Because every time someone's accessing the palette, it's looking in user defaults. And every time they're saving it, it's saving in user defaults. So we've kind of changed our model for our palette store to be a bunch of palettes stored in user defaults. And imagine this was a SQL database or something like that. Our model would be some SQL database, tables and rows. Well, now it's this user default thing because we're directly storing it. We don't actually store it as a local variable anymore. We always go to the source, the data, just like we would always make a SQL call to go get the data if we were doing a SQL database. Everyone understand why the source? Now, of course, this doesn't work. We got some errors here. It says, property wrapper cannot be applied to a computed property. Oh no, we need that to be @ published, otherwise our view is not going to update. What are we going to do here? Well, what we're going to do here is we're going to understand how @ published works. What does @ published really do? Well, I told you that if you have a class and it implements observable object, that there's a free var you get. Remember this? Var object will change. And I said we don't need to put it in here ourselves. It's kind of, we get it automatically behind the scenes. Well, that var has value. And that var is the var we use to tell the view something will change. So be prepared. You might have to update. And that's what @ published does. @ published, whenever you change that var, it calls this thing's send function. Well, if we can't be an @ published here, if we have to take @ published away, then we can call this directly. There's no reason. In fact, it's normal to call this in this case. So when we set it here, I'm going to say object will change dot send. That's how you send this message that, hey, this object will change. When you say object will change, by the way, what you're saying to the view system is keep an eye on this because it might change. And the next time you do your pass to update the whole UI, look at this thing and see if it has changed. So object will change doesn't always mean that it's going to change, but it means pay attention to this, Mr. UI, because it might change. That's why it's object will change. It's notifying it to look out. While I'm here, by the way, there's no reason I have to give up my nice feature in my view model where I don't allow this to be empty. Remember, I don't allow my pals to be empty. I can do this really easily here. I can just say, if this new value is not empty, so not new value is empty, then update it. Otherwise, ignore it. In other words, ignore any attempt to set this palettes to be some empty array. Now I've got that same thing. So I don't need this object will change. Even if I'm using it, I don't need it. So just leave it out of there. You can use it anytime you want to tell the view, hey, I'm doing something that you need to pay attention to. It might change. You cool with that? Now we got an even bigger problem though. I've used the function palettes for key in user defaults. No such thing, right? Remember from the slides, there were things like integer for key and float for key and data for key, string array for key, but there's not something called palettes for key. Palettes, that's my thing, okay? That's inside my app. So how do I fix this? Anyone have an idea how we can fix this? Bingo. Let's add an extension to user defaults to do our custom type here. And how are we going to do that? We're going to use data as a thing, and we're going to JSON ourselves. And that's how we'll store ourselves in there. So it's going to be really easy to implement this little function. And on the saving side, everything is set up to work too. So we can just provide a little set that JSONizes our thing. So let's do that up here. Extension to user defaults. And I'm going to add a func called palettes for key, which takes a key and returns an array of palette. And then I'm going to have another function, set palettes, array of palettes for key that sets them. And now that I put these here, look, no more errors down here. Of course, I have to implement them, but look, everything's just fine. So how are we going to implement this? Let's do the set first. The set is really easy. It's basically a one-liner here. So I'm going to say, let data equal trying to JSON encode my palettes. Right? Palettes that were passed in here, try to encode them, and then set, I'm user default, so I can call set on myself for key. And this is setting it as data. This is a data object. What's the problem here? JSON encoder requires that palette conform to codable, of course. How can we have an array of palettes get JSON encoded if palette is not codable? No problem. We pop over here to palette. Let's make it codable. And when we do this, we get an interesting warning. Immutable property, ID, will not be decoded because it's declared with an initial value that cannot be overridden because it's a let. we made our ID be a let. That means it is set at creation time and can never be set again. Well, when you're decoding yourself, it creates an empty palette and sets all the vars. That's what decoding means, right? So we can't have any of our vars that are going to be decoded be lets. They have to be vars. So this has to be a var. And it's still going to get that nice initial value when we init it, when we call it initializer, but then when it gets decoded, it can be reset back to what it was when it was stored by the encoder. While I was here, I actually noticed another bug that I put in this code, which is my built-ins. You see my built-in is a static let, which is an array of palettes. If I were to create two palette stores with different names, both of them set to built-ins, they would end up having palettes with the same ID. Because this built-ins array, these palettes, when I create them, they get an ID. So I can't do that. I'm going to fix this really easily, though, by making this be a var, which is of type array of palettes. And I'm going to have it be computed to return this array. That means every time someone asks me for my built-ins, it makes new ones. It runs this code, this computed, so it runs it again, and I get new ones with new IDs. So go back to our palette store. This code right here should work now. It does, right? Because palette is now codable. What about this code right here to get our palettes out? Well, we just have to decode here. So I say if I can let JSON data equal myself, I'm a user default, the data for key, the key that we want to pass right in here, then I can try to let decoded palettes equal trying a JSON decoder to decode. And what's the type that I'm trying to decode? Right? We're trying to decode an array of palettes. That's what we encoded right here. We encoded our palettes. That was an array of palettes. Now I'm trying to decode an array of palettes. And yes, it's perfectly legal to say array of palettes dot self. Array of palettes is a type. Maybe if I wrote it array angle bracket palette, you wouldn't be disturbed by it, but it is just that. And where's it coming from? Of course, it's coming from that JSON data I just got from myself by doing data for key directly. All right, so now I've checked those things. And if those things both work, then I can return these decoded palettes. And if they don't work, if there was never stored or somehow it got corrupted or who knows what, then I'll just return an empty array of palettes, which is fine. Just my palette store will be empty in that case. So one other thing that we need to do here, which is in our init, we always set our palettes to the built-ins, no matter what. We only want to do that if the palette is empty. So I'm going to say if my palette is empty, then I'll use the built-ins. Otherwise, I'm going to use whatever I find in user defaults. All right, we have vehicles, delete vehicles, add math. User defaults, that persistent dictionary, it doesn't write to disk every time you store in it. It buffers up the changes and writes it out when it thinks maybe you need to. For users, this is not really a problem because it writes it out every few seconds or whatever. But when you're in Xcode and you're killing your app really quickly, it doesn't always get a chance to write out. So how can we fix that? The best way to make it do it is switch to another app. See, if you switch to another app, then your app is going to be like, I'm not going to be the active app anymore. I better write my user defaults out. So that's a good way to force it to do that. Go back here, run again. All right. There's math and no vehicles. There's one other thing I want to do here for code cleanliness, which is I told you about the fact that this user defaults.standard, we're going to use this through my whole app. And I don't really like the key for my palettes to be main. That's the name of my palette store, right? Palette store name, you see it at the top there, let name string. It's called main. Back in my Emoji Art app, right, I called this palette store main. That's kind of a generic word to be a top level key in this little lightweight dictionary. So I'm going to do this, and I recommend strongly doing this. say create a little private let, I'll call it my user defaults key, which is a string, and I'll compute it by saying something like palette store colon plus my name. Now I'm storing the thing under palette store colon main. That's a much more unique top level key. This is a var. So let's use this when we're using it for our key to store things. Now if I run, it's going to lose all those changes that I made because now it's looking in a different key. So vehicles is back, right? And no math. But here, if I don't know, let's delete animal faces. We'll switch to another app to force it to do its thing. Go back here, run. Hopefully we have no animal faces. And we don't, no animal faces in there. Okay, that's it for the demo for today. We're gonna go back to the slides. Any questions about that? We saw a lot of stuff there. Codable, throwing and trying things. We saw writing to the file system. We saw writing to user default. A lot of things going on there. Not a lot of code, but a lot of conceptual things happening. All right, let's talk about these property wrappers that we see all over the place. When you see a property wrapper like @state, what's actually being created there is a struct. So these structs encapsulate some kind of behavior that you always want to apply to a certain variable. So let's talk about some of these things that we know and see what they do. Well, @state, what does it do? Well, it moves the storage into the heap so that as the view is rebuilt all the time, the value stays, right? It keeps the state in the view. And it also causes the view to redraw itself anytime that @state changes. What about @publish? Similar, right? Every time something changes in that var, it calls object will change.send. And how about observed object? Okay, that causes a view to redraw when it sees object will change.send sent, right? So that's what these things are doing. They're doing a little extra behavior all the time when that var changes. Property wrapper is a feature in the Swift language that allows you to create these things, and then it has syntactic sugar. So let's look a little at the syntactic sugar that you get. And we're going to use @publish as an example. So I have this @publish var emoji art, which is an emoji art. We're going to look through what this is. This is actually going to be a struct, not a emoji art, but a struct. Now, the name of the struct, watch now, there's going to be some animation here. The name of the struct is the name of the thing. It's going to create a struct of type published. And inside, it's always going to have a var called wrapped value. And this wrapped value is always going to be of type, the type you specify. Now, sometimes we notice we don't specify a type. Remember @namespace? We didn't say @namespace dealing namespace colon namespace. We didn't specify it. So sometimes the struct knows its own type on the inside. You don't have to specify it. But other times it gets it from there. And again, this is all part of the property wrapper feature that it can get it from there or just define it itself if it wants. Now, once it builds this little struct for you, Swift makes some vars available to you. The first one is underbar emoji art. We've never seen this, but in your code, you could refer to underbar emoji art. And what that is, it's of type published, and it is the published, initially set to the published with the wrapped value being the thing you set the initial thing to. So underbar emoji art is an instance of the actual struct, the published struct. And it's got wrapped value in there. This is a little bit pseudocode because this would actually be something called initial value. The initializer for the publish, this would call initial value, but I say wrap value because it's setting the wrapped value basically. Almost all struct like this would set their wrap value that way. So that's underbar emoji art. And I'm going to show you a little later when you might actually use this. You might want to actually get at the struct that the @publish created for you. Then the next var that you get, of course, is the var you've been using, which is this var emoji art. And this is a computed property, believe it or not. You've been using this thing left, right, and center, but it's actually computed. It gets and sets the wrapped value of that struct, right? The underbar emoji art is the actual struct. You're getting the wrap value and setting it. This is important because it's setting and getting here, so we can do those other things. Object will change.send and all the other things it wants to do. it can do that in here. We'll talk about that on the next slide. But wait, there's more. There's another one, another var called the projected value. So this struct can have a var called projected value, and you get that var $sign emoji art. And we actually have seen this once. Do you remember it? $sign gesture state. Remember the gesture state we had there? That actually was using the projected value of the @ gesture state. Now, projected value, what is that projected value? It can be anything the struct wants. So different structs, published has its own projected value of a certain kind of thing. I'm going to talk about what that is right here. But other ones like @ state, they have their own projected value, which is different. @ observed object, it has its own projected value. It's different than published. You see, they all can vary. And I'm going to go through all of them and what their projected values are in a second here. Published projected value, this $sign emoji art, is what's called a publisher. Now, I'm not going to talk about what publishers are. They're essentially things in Swift that know how to publish things on a stream, basically a stream of information being published out. So you can imagine here the stream of information is the changes to this variable. But ignore this. But I am going to talk about the $sign for all these other things. Why do we do all this? Why do we have this @ state and @ publish and have these? Well, because we obviously have something we want to do that's the same for a lot of different vars. We have all our @ states. They all want to do exactly the same thing. Get put in the heap, cause our view to update. So we want to collect all that code in a nice place. That's what these property wrappers allow us to do. All right, so let's go through each of these. So @ publish we talked about. What does it do when its wrap value is set? Well, we know what it does. It publishes the change through its $sign thing. That was that publisher. We don't really care about that. But it also invokes object willChange.send in its enclosing observable object. That's what @ publish does. And let's look at some of the other ones. @ state. So the wrapped value in an @ state can be any type, as we know. And what does it do? Well, it causes that wrap value to be moved to the heap and stably kept there as the view is constantly changing, and it invalidates the view whenever that value changes. That's what @ state does. Makes sense. Now, what is its projected value? It's $sign. Now, notice I put all the $sign things in bright purple here because this is all new, and so this is going to take some getting used to. The $sign of an @ state is what's called a binding. So a binding is another @ thing I'm going to show you towards the end of these slides. And once you have this binding, you can give it out to other people, and now they are bound to your value. And this is a way that I can pass my @ state value to other views, and when they change it, it changes my state. So it's like a reference. You want to think of it that way? It's like a variable that's bound to my @ state. And we're going to talk about why this is so important in a few slides here. But that's @ state's binding, @ state's projected value. Its $sign thing is a binding to that @ state. I just want to say one thing about @ states. Sometimes you want to initialize your @ state in your init. In this class, we've only initialized our @ states with equals something. But you might want to do it in your init. It's a little tricky. You actually have to do it by setting the underbar foo, the actual struct, the state struct. You can set it to either state, you could say state of the right type, or you can just say .init, initial value 5, and that will do it. I remember I said before this was wrap value, but it's actually initial value. So here I'm directly setting the state struct, the thing of type state struct. You don't have to do this much, but you know where you do this a lot? On up here. So you would set the state to 0, or it'd be an optional or something, and then in your on up here, then you would set the thing. You don't have to do this underbar. All right, how about @ state object and @ observed object? Okay, the wrapped value there is anything that implements the observable object protocol. So it has to be a class, your view model, basically. That is the wrapped value of these things. Now, what do these things do? Well, they invalidate the view when the wrapped value does object willChange.send. That's what they do. When they see that object willChange.send in their wrapped value, they invalidate the view. And we know the difference between these two, right? At-sign state object is a source of truth. Its lifetime is tied to the view or the app or something called the scene we're going to talk about that it's in. That's its lifetime. And observed object, we never set it to an initial value or anything like that. It always gets passed into us because the source of truth for an observed object lives somewhere else. It gets passed into us. But they both do exactly the same thing after that, which is they do this object will change dot send invalidation. What's the dollar sign of an at-sign state or at-sign observed object? Super important. It's a binding to all the vars in the view model. So you can use the dollar sign of a state object or an at-sign observed to get to any of the vars in your, not just the published ones, any of the vars that are public inside your view model. And you can even go multiple levels down, and you can even do arrays. So you can access something in an array and create a binding to it. And the fact that it's a binding to this means that if you change it, it's changing it in your view model. The source of truth remains in your view model, or maybe in your model, because the var that you're accessing might be one of your model vars in your view model. The source of truth remains the same. You have a binding to it, so you're changing it in the source of truth. All right, what is an at-sign binding? Well, the wrapped value of an at-sign binding is a value that's bound to something else, either an at-sign state or some view model through at-sign observed object and at-sign state object. What does an at-sign binding do? It gets and sets the value of the thing it's bound to when you get and set its wrapped value. So it's a reference, right? It's remotely changing that other thing. The other thing it does, very importantly, it invalidates the view it's in. An at-sign binding is going to be in one view, it's going to be bound to the state in another view. When the value changes in that other view, it's going to cause the view that has the at-sign binding to get invalidated, you see, because it's bound to that other one. The projected value of a binding is a binding to itself. Or if you want to think of it, it's a binding to that original thing. So if you take a binding, a dollar sign of a binding, you get the same thing back, basically. It's like self. You can think of it that way. Where do we use bindings? This at-sign binding thing, where do we use it? We use it all over the place. We use it to get the text out of a text field, right? A text field is like an editable text. And when you type in there, the text you're typing comes to us via a binding to some state that's inside that text field. Also, toggling. So if you put a toggle on screen, which you press it and it turns on, off, the on, off in the state, you bind to it. So when you create a toggle, the argument you pass is a binding. And it could be a binding to something in your view model, right, using observed art, or it could be a binding to an at-sign state. Either way, because both of those things have the dollar sign thing. We saw the binding to our gesture state. When we did the updating gesture state, we used dollar sign because we wanted to be bound to that gesture state. Modally presented views. When we put other views on screen, we want to know whether they're actually still on screen or not. That's bound to us via binding of a is presented Boolean inside of there. We use bindings all over the place to break our views up into smaller views, where when we break it into the smaller view needs to refer some state in the bigger view, right? So the bigger view will pass some binding to its own state. And so many more places. You're going to start seeing bindings everywhere. In fact, I'm amazed we're able to get this far without talking about binding, because it's really absolutely everywhere. Now, bindings are all about single source of truth. We only want the source of truth to be in one place. And if we need to use it somewhere else, we're going to pass a binding to it. Now, the single source of truth is usually our view model or our model, but sometimes it's at-sign state. We have it in at-sign state. If it's a little temporary truth just about the UI, it might be an at-sign state. And that's why the projected value, the dollar sign of our at-sign states and of our observed objects, is a binding to those things. We want to bind to the source of truth at all times. We never want to copy the source of truth. We never want to say, you know, I'm going to have this view do something, I'm going to pass this value to it and have it copy it, and now they both have it in an at-sign state. We want one of them to have it in an at-sign state, one to be bound to it. We see this in this kind of code right here. So I've got my view up at the top, and it's got some at-sign state, and then I've got another view down here, and it wants to put up a text field that edits that @sign state. So it does that by declaring a binding, and then this guy, when he calls it, he says shared text $my string. That passes a binding into this shared text, and now down here in text field, this argument is also a binding, and so the text field is bound through this binding back to this state. This, what you see right here, this pattern, was do all the time. This is how we pass some @sign state to another view and still retain the source of truth in ourselves. So this is a slide you're going to want to go back and look at later, fully absorb what's going on here. Of course, we're going to see it in the demos all over the place on Wednesday. On Wednesday, we're going to start doing, I kind of packed up all the binding stuff into one big lecture. We're going to do a lot of @sign binding there. But the bottom line is, my string up there that's hello, which is @sign state, is being changed by this text field down here through this binding, which we got from $signing that state. You can also bind to constant values. If you binding .constant with a value, you can bind to a constant value. That's useful in previews and things like that where you don't want it actually changing. And you can also compute your own binding. You can create a binding where you get to do the get and set. So you can actually create bindings that will bind to anything you want, and you could even put your own code in there to do something when something changes. That's a little bit of advanced topic. I don't expect you to do that for your final projects or any homework, but just something to know that's possible. You go look in the binding doc under the get set initializer there. We're running out of time here, so I'm going to really blast quickly through environment object. You know what that, its wrap value is the observable object that was injected into it by .environment object. We already covered this. Its projected value is also a binding to the vars of that thing. And then there's @sign environment. This is the last one. This is the only one we haven't talked about yet. It's not anything to do with @sign environment object. It's a kind of an interesting property wrapper because when you create it, it actually takes some extra arguments. So I can say, for example, @sign environment \.color scheme, var color scheme, and that will create a little var called color scheme, which will represent the color scheme, dark mode or light mode, of your current running process. And all of these things that @sign environment can specify there are in this very important struct that you should really look at and look at the entire documentation for, called environment values. You'll see color scheme in there. You'll see a bunch of other things. It's really nice for just knowing what's going on. Am I in landscape mode or I'm in portrait mode? What's my color scheme? All that stuff is an @sign environment with a certain \dot something that you can go look at in this environment values struct. So go check that out for sure. Notice that you don't specify the type there. The color scheme is no colon something like @sign namespace was. That's because it depends on which environment variable you're looking at. The color scheme is a enum with dark and light and other things that's built into environment. It just happens automatically there. To summarize, the @sign environment's wrap value is the value of some var in that environment variable's place, and its projected value is nothing. So you can't have a binding to those things. Okay. Some of the environment variables themselves are actually bindings, but that's a whole different thing. That is it for those @sign things. A lot of going on there. Most of the @sign things, you just learn them by using them. Like you already have @sign state, @sign observed object, @sign state object. You know how those work. @sign published. So you don't really need to know the details there, but I wanted you to kind of see behind the scenes what the heck is going on there. You don't actually have to know anything that I told you just there to use those things. You just have to know what they do. So on Wednesday, gigantic demo where we're going to start putting more things on screen. Right now, all our apps had just one view that's always on the screen. Now we're going to put other views, popovers, and things like that. We're going to start creating complex UIs with forms and lists, navigation, going around to different views and coming back, all that stuff on Wednesday. It's a humongous demo, probably the most important demo I do of the quarter. It'll be all demo all the time. And again, sorry for holding you over 10 minutes here. I'll never do it again, I promise.